Hi guys, welcome back to my YouTube channel. So first of all guys, mag-shoutout muna tayo. Shoutout kay Engineer Ivy Dayan Corpus. She is a civil engineer and she is a subscriber of this channel. So thank you for subscribing on this channel. I hope that you stay safe and stay safe dyan sa site because she is a site engineer. So in this particular video guys, we are going to solve a random engineering science problem. So this is statics. So hindi ko na siya label as engineering math because this is under sciences. So in this problem, we have a beam rests on a fulcrum 1.2 meters from one end. A weight of 350 kilograms is suspended from this end causing the beam to balance. If the weight of 350 kilograms is suspended on the opposite end of the beam, it is necessary to suspend a 1,000 kilogram weight on the first end to effect an even balance. Find the length of the beam. So the first step in solving a statics problem, engineering mechanics guys, no? Pag nag-solve tayo ng statics, always start your analysis, of course, on the problem, and kailangan natin gumawa talaga ng free body diagram. That's your FBD. So it's the most important part of your solution. So you need to construct your free body diagram or your FBD. We need to understand what a fulcrum is. So a fulcrum is a point on which a lever rests or is supported and on which it pivots. So basically guys, magpipivot doon yung ating beam. So it's a support. Okay, for example, here may support tayo. Let's say triangular yung kanyang shape. So this is our fulcrum here. And nagre-rest dito yung ating beam. Okay, magpipivot siya dito sa ating fulcrum. So let's say, sabi dito sa problem, 1.2 meters from one end. Let's say it's 1.2 meter here to the left of the beam. So let's say this is the beam. Okay, so let's say that this distance here, say that this distance is 1.2, okay, 1.2 meters to the center line of your fulcrum. So dito guys, hinanap natin is find the length of the beam. So let x natin guys, let x be the length of the beam. Okay, lagyan natin ng variable for that unknown value. So we need to find this x. A weight of 350 kilograms, so this is a force, okay, kilogram force siya because this is a weight, is suspended from this end, okay, from this end of the beam here. So from this end, meron tayong force that is 350, okay, kilogram of force. Then another force that acts here guys sa ating beam is actually the reaction at the fulcrum. Okay, may reaction sa fulcrum. We have here, so let's say this is Ry and we have here Rx. So that's the reaction on the fulcrum. Other force that's acting on this beam is the weight of the beam itself. So yung ating weight guys ng material, mag-act siya the centroid of this length x. So basically, mag-act yung ating weight here at, say, weight of the beam at a distance of 0.5 or 1/2 of this x. Sa gitna siya, mag-act. So this is basically, so we have here 0.5x on the left side. So dun mag-aak yung weight ng beam natin. But it's not given. But it's needed for us to formulate the equation. Okay, mag-sum tayo ng moments about the fulcrum. Let's say that this is point O. Okay, summation of moments about O should be equal to 0 for statical equilibrium body. Okay, mag-assume tayo ng direction. Palaging ina-assume ko guys na direction is you have here counterclockwise positive moment. This weight here, itong weight na 350 kilograms, it produces a moment. So, mag-moment tayo about here. Okay, so if this is your force, 350, it tends to rotate about this point. Kung ma-imagine natin, no, if this push here, iikot yung ating beam at a counterclockwise direction. Therefore, yung moment ng 350 kilogram force about this fulcrum is actually a positive moment kasi iikot siya dito at a counterclockwise direction. Since ang assumption natin counterclockwise positive, this is a positive moment. So that is 350, okay, times yung moment arm natin. So that is 1.2 meters. So wag na muna natin ilagay ng units. Then, yung ating weight, kung ito mag-push yung weight natin dito, if it pushes here, yung ating beam it will actually tends to rotate at a clockwise direction. So therefore, yung moment ng weight ng beam about the fulcrum is actually a negative kasi mag-produce siya ng clockwise moment. So this is the moment arm from this force to this fulcrum. Ito yung distance niya. Okay? So since ito, the distance from here to here, okay, that's 0.5x kasi mag-act yung ating weight sa 1/2 ng length niya, which is 0.5x or 1/2 x. So this distance here, this distance here from the weight to that fulcrum is actually 0.5x. I-minus natin yung 1.2 meter. So this distance here, itong distance na to, dito na lang natin ilagay, hindi na nagkasya sa figure. So this distance here is 0.5x minus 1.2. So this is 0.5 here, 0.5 yan. Then isubtract natin itong 1.2 para makuha natin itong distance na yan. That's the moment arm of the weight of the beam on that fulcrum. So that is 0.5x minus 1.2. So this is a negative moment. So force times distance, so negative. So WB, that is 0.5x minus 1.2. So no other moment kasi yung RX, RY nag-act siya dun sa fulcrum, therefore yung moment niya is 0 kasi dun tayo nag-moment. Wala siyang moment arm. So that is equal to 0. So this will be our equation 1. This is equation 1. Then proceed tayo sa other condition. So i-drawing ulit natin guys yung beam. So we need the second equation to find x. Okay, kasi yung first equation natin, dalawa yung variable, we need to formulate another equation to find yung x natin, which is the length of the beam. Okay, ginawan tayo dito ng second condition. If the weight of 350 kilograms is suspended on the opposite end, so doon naman sa kabila siya na suspend. So it is necessary to suspend a 1,000 kilogram weight on the first end in order to effect an even balance. Ibig sabihin, pag nilagay daw natin doon sa other side yung 350, then maglagay tayo ng 1,000 kg doon sa left side, magi-even pa rin or magbabalance pa rin yung ating beam. So on this side, ililipat daw natin dito sa kabila yung 350 kg. Then maglalagay daw tayo ng 1,000 kg force dito sa other side. And this distance here from the other end, from the left end, that is 1.2 meters. No changes for that. Okay, so this distance here, 1/2 of the length of the beam, 0.5x. So this length here, the length of the beam is x. So let's formulate again another moment equation. So summation of moment about the fulcrum, so point O equals 0. And again, assumption natin, counterclockwise moment is positive. Ito, ang distance ng WB from this fulcrum is, that is just 0.5x minus 1.2. So, hanapin natin yung moment about point O. So, this 1,000 kg force, imagine natin guys, no? If you push here, 1,000 kg force, iikot siya, tends to rotate yung beam natin, it will tends to rotate at a counterclockwise. Yung 1,000 is positive. So this is 1,000 times moment arm natin, that is 1.2. Okay, so yung weight ng beam, again, that is actually a negative moment kasi if you push here, iikot yung ating beam at a clockwise direction. Ang assumption natin is counterclockwise positive. This is clockwise, this is negative. So, minus WB. So, that is 0.5x. Ang moment arm niya is 0.5x minus 1.2. Then, we have this 350. That is actually a negative moment kasi ang ikot din niya, if you push here, iikot yung beam natin. Imagine, if you push here, iikot yung beam at a clockwise direction. So, this is negative 350 kilograms. So, wag na natin muna lagyan ng units. Yung moment arm natin, yung perpendicular distance from this point to this point is, okay, so if this distance is x, So this is 1.2. So this distance is x minus 1.2. So this is the moment arm of the 350 kilogram force on the right side opposite of the beam. So this is times x minus 1.2, that is equal to 0. So this will be our equation 2. So using equation 1, from equation 1, that is, we can find x now, the length of the beam. Equation 1, that is 350 times 1.2. So 350, that is 350 times 1.2. So minus WB, that is times 0.5x minus 1.2 equals 0. Okay, from this equation 1, W sub B times 0.5x minus 1.2 is just equal to, transpose natin, this becomes 350 times 1.2. Ayun. So itong value, this value here, ilipat lang natin siya, substitute natin tong value doon sa value for equation 2. And this value for equation 2 is just 350, reducing your equation into a one unknown equation. So we have here 1,000 from equation 2, 1,000 times 1.2, so minus ang W sub B times 0.5x quantity minus 1.2, that is just 350 times 1.2. Okay, so we have here minus eto 350 times x minus 1.2 equals 0. We can find x now. So combine natin to, transpose natin to the other side. Ito. So 350. So that's just 350 times the quantity x minus 1.2 equals. So ito, this becomes 1,000 times 1.2 minus 350 times 1.2. Okay, divide natin both sides by 350. So x minus 1.2, that is just equal to 1,000 times 1.2 minus 350 times 1.2 all over. So we have here, dinivide natin sa 350. Okay, then add tayo ng 1.2 to both sides. So x is just equal to 1,000 times 1.2 minus 350 times 1.2. That's all over 350. Then we have here plus 1.2. So that is the length of the beam. So x equals, ang unit niya, lalagyan na natin ang unit dito guys, this is in meters kasi naka meters yung 1.2 natin. And this 350 and 1,000, 350 here is just unit of force, mag-cancel yung unit niya. It leaves us a unit of meter because 1.2 here is in meters. So if we are going to use three significant figures, the length of the beam is approximately 3.43. Okay, that is 3.43 meters. So this is the final answer for this practice problem. Okay guys, practicein natin mag-solve ng mga ganitong problem because this is very frequent in our board examination. This is under statics. Again, mathematics and engineering sciences in almost all engineering board exams are composed of 35% of your overall rating. So this is medyo mabigat itong mathematics and engineering sciences for your chances on passing the board exam. So that's it for today's guys. Thank you for watching this video. If you are new to this channel, can actually subscribe and click that notification bell so that you'll get notified on our future videos just like this one. See you guys, stay safe, and God bless you all.